today. Big thanks to everyone that's able to attend a lunchtime meeting. Let us know if you like this cadence and time at all. But today we will be doing a ventilation training covering the ASHRAE 62.2 code and requirements specific for home performance. And today the training will be led by Steve Spatz and Matt Sharp. And we're here today mainly just as this has been an upcoming topic in home performance as the shift to ASHRAE 62.2 this year and the need for ventilation coming up more and more with home. So just a time to make sure we're all on the same page. What are the requirements? Program answer any for Q&A. Free to put any of your questions in the chat as we go along, or feel free to come off mute and ask them audibly if you want. But with that, I will pass it over to Steve Spatz to take it away.
All right. Thanks, everyone. Appreciate you coming to listen to us talk at you here for a little bit today. Yeah, as Juliana noted, we had the program shift from previous standards that we've been referring to for use for ventilation requirements and home performance to the ASHRAE 62 2016 at the beginning of this year. For those of you who've been in with us for quite a long time in our program, this is a significant departure from the early days of the building air tightness standard from BPI and some of the other methods that have been used to evaluate ventilation requirements in the program. So felt this was important to level set with everyone, give you the actual formula of what we're talking about here now, how it applies to existing homes primarily. This standard is required for ventilation in the Vermont Residential Building Energy Standard. It's also just the industry standard for ventilation design for residential buildings, as is the ASHRAE 62.1 for commercial buildings. So we're going to get into the details of the standard and then also talk about the application of this in homes, like what are your options to comply with the ventilation rates that are going to come from the ASHRAE 62.2 calculations and the standard that's required for the types of homes you're working in. So Mr. Sharp and I are going to present on this. Matt's going to take the first chunk here to kind of go through the standard itself. So, Mr. Sharp, if you're ready to go, I'll hand it off to you.
All right, thanks, Steve. So, hello, everybody. I'm going to get into the standard, and then Steve's going to get into sort of the applications of it. And just a refresher, the old BPI BAS standard, BPI changed their standard somewhere around 2015. I don't know the exact date. And so after that, we had people joining the program who were trained under the 62.2 ventilation standard, and others who had been around longer who were trained under the 62.89 standard. We allowed both for quite a while up until the beginning of this year. And so we were here in front of you the end of last year, about the same time, actually, October, I think, presenting a very similar demonstration of how to go about complying with 62.2 and just clarifying that 62.2 is the standard now for home performance with Energy Star. So I'll write just a snapshot of what that standard is. It's a national standard, very well accepted around the country as the standard to use. It has a formula. You can do the formula out longhand. It's 0.03 times the conditioned square feet of the space plus 7.5 CFM per bedroom plus 1. So the number of occupants is determined as bedrooms plus 1. There is an infiltration credit using a blower door test result, and that is a little harder to do longhand. But we'll show you in a minute a tool that you can use that makes this all very easy. And if the result of that tool allows or requires 15 CFM or less, then the standard basically says you don't need to add ventilation if you're that close to infiltration serving the bulk of the ventilation needs. So next slide, Steve.
Hey, Matt, is there would you want to mention like kind of what we're seeing as far as where we're landing with air tightness with buildings and where we start to see the need for ventilation come into play? I mean, there was a kind of square footage correlation that has been kind of showing up in some of recent projects. I think that's worth mentioning.
Yeah, I wasn't sure if that's farther down in the slide deck, but we have been just doing a few examples. We see a little bit of a correlation between the finished square footage and the blower door test result. So if you have a 2,000 square foot home that's testing 2,000 CFM50, you're at sort of that line where you are likely to have to put in ventilation, a ventilation system. But that's just a loose sort of guideline. You always go by the standard to determine if you actually need to. Question in the chat, we'll get into that in a few slides, I think. So the tool RedCalc is now on the PNNL site, and there's a link right there. Hopefully many of you are already very familiar with this tool. Makes it pretty easy. There's basically 4 inputs. After you put in your building location and that you're an existing building using infiltration credit, you basically have floor area, number of occupants, dwelling height, and the measured leakage. And then the output is going to be what your annual infiltration rate is, what's covered by the infiltration credit, and then what's left over that you need to provide by mechanical ventilation, if any. And again, we have more details on this in the next slides to come. Next slide, Steve. So there again, another link. You can use the infiltration credit here. And what I'd want to stress to folks is anticipate your test out results, because it's really at the end of the day what you're bringing the building to as an ending condition that's going to determine whether ventilation is a must-have or a recommended improvement. And so if you do this RedCalc on the test in, you know how close you are. If you think you're only going to get 10%, you can plug that into the tool and see if 10% reduction gets you there. If you think you're going to get 20 or 30%, plug that anticipation into the tool and you can have an idea as to whether ventilation really ought to be written into the scope. Of course, it's never a bad idea just to write ventilation into the scope, especially if you are insulating an area around a bath fan. It's a really good opportunity to replace that fan and improve the vent to assist to something that can be a ventilation system in case you get that tight or in case the owners just want to have that anyways. Fan requirements that again we'll get into more detail, but for a fan to be eligible to be used as a ventilation system, the fan needs to be Energy Star rated or equivalent. So Energy Star or equivalent, a lot of the fans will have that little square Energy Star logo right on the nameplate. That's indication that, okay, I have a good fan here that can qualify. Several, like all the main name brand fans make Energy Star models, whether it's Panasonic, who I think makes only Energy Star models. Broan has some Energy Star models, Newtone, lots of different systems potential out there. But what's pretty clear is if it's one of those old loud fans, it's not going to be a qualifying system. And even the new fan, some of the new fans are fairly loud and not Energy Star and couldn't be used as a system. Next slide.
The key
Steve.
here is the low zone, so low noise and low wattage are kind of the key things in the requirements for what the fan needs to have to be used as a system. And again, as Matt said, that falls under the Energy Star criteria.
Yeah, and if you have any questions about the fan you are seeing, take a picture of the nameplate, ideally, and we're happy to track down, help you figure it out. But a lot of times the zone rating will be listed right on the nameplate, along with the voltage and the amps, and that you can determine whether it's low wattage and quiet. So back to the tool. Another picture of the tool with those really 4 primary inputs of floor area, dwelling height, number of occupants, and your blower door test result. And I think, Steve, the next slide has description.
I'll mention on this too that there's the use advanced blower door inputs. That's an optional section that you can use in the tool. By default, that box is not checked. But what you're using there is that it's giving you adjustments based on temperature. But if you use the software with your blower door and it's already made those calculations, you don't need to use that advanced blower door input. So it's at your discretion. By default, when you access the tool, that section would not be showing as a section to input. You can click the box to use it if you want to use it.
So key inputs, height of the building. And the height of the building is defined as the vertical distance between the lowest and highest above grade points within the pressure boundary. So this example that's showing H, you follow that dotted line over from the top and you see you're at the peak of the roof. This is indicating that the thermal envelope of this building is up the roof peak, up the slope to the peak. And so that's the highest point of this building. If this was just a totally open attic with no vaulted ceilings, then the height would be down at that, typical 8-foot flat mark. And then the lowest point is going to be, if you have a walkout basement, then it's going to be the bottom of that walkout. So jumping into our basements included. So the way ASHRAE defines it is that you want to include all above and below grade finished areas and unfinished occupiable spaces. So occupiable space is defined as a space within the pressure boundary that's intended for human activities. And I would say for the most case, like cellars, your typical cellar type of scenario, that's not really occupiable space. But you very well might have a basement that's not finished, that, there's a TV and a couch down there, and there's an exercise room, and it's clearly occupied space. Use your judgment on that. You're going to have to recognize what condition you're seeing and note whether that's occupiable space or not. And if it is, include the square footage of that space. The ORC input for conditioned square footage really should align with what you're determining is ASHRAE occupiable space. And we have a question.
Yeah, I have a question. Is Bradley triangulation? So for the ASHRAE, ASHRAE has a video of how to do all this stuff, and from the guy who built this ASHRAE, who in 2016, he is saying on his own video that you do not add the below grade finishes, even if it's unfinished occupied space, like how you just said right there. He said it has to be completely drywalled, completely sealed off and finished in order to be even adding that to the ASHRAE, even if it's like a unfinished basement with a TV and a couch and everything, you still would not add that to these ASHRAE model. That's what he says on his video. So
I think that would be a fair assessment. It is up to you to determine whether that's occupiable space. And I think, like with a lot of things, sometimes spaces need ventilation or should have ventilation. And if we're crossing a line between what we require and what should happen, hopefully what should happen happens. and hopefully that aligns with what's required. At the bare minimum, you got to use the finished spaces as occupiable. If you come across a space that you feel really ought to be ventilated because it's occupied regularly, I'd say include it.
Should we put that on, I guess, our like test out in the portal, how we did our ashtrays? So like if you guys ever did inspect it, you guys don't think like I did it or someone did it wrong because you guys did one way and we did it another way. So I'm trying to be clear so we're both on the same page. So we're not doing two different ashtrays for the same house, thinking about a space that are basically the same.
Yeah, I mean, I think notes are always helpful, and I think Steve's going to cover at the end maybe what's required for submittal.
Okay.
But you know, I think if there was ever a situation where we got a different result, we'd call you and figure out why. You know, and we can
Yep.
resolve it hopefully pretty easily.
Yep. Sounds good.
The main
Yeah,
point,
and the
I
link,
think, is do the calculation and include ventilation. And, you know, let's get
Yeah.
into these little tiny details about how and what to include.
No.
Let's
Yep.
work through them as they come up.
yeah, and the
Sounds
language
good.
that we're using here in this section, you know, defining how to determine what's conditioned space is the language that comes directly from ASHRAE. So this is, you know, language from the standard itself. So, you know, we're going by what the lay of the land is according to ASHRAE here.
All right. Sounds good.
You want to jump to the next one, Matt, or are you still?
Yeah, jump to the next one.
All right.
Number of bedrooms versus number of occupants. So the ASHRAE formula calls for number of bedroom or number of occupants to be number of bedrooms plus one. And the idea is that there's a ventilation system that is in place that serves the dwelling unit regardless of how it's currently occupied. And so if it's a 2-bedroom home, it's considered that one of those bedrooms is a primary bedroom that would be occupied by 2 people, and every other bedroom is occupied by 1 person. So you have that number of occupied or occupants is 3 in that case. So the smallest, the minimum number of occupants you could have is 2. That would be a 1-bedroom scenario for you. So it's a 1-bedroom plus 1. You know, if you get into a situation where there are obviously more occupants than the number of bedrooms plus 1, this falls into that, like, you really should size based on the need of that increased occupancy. Now, yes, the requirement says number of bedrooms plus 1. But when you're in that situation, if you have 8 occupants in a 3-bedroom place, you know, do the right thing and size it for the number of actual occupants. So basically what we're saying is whichever is higher, an actual number of occupants or a number of bedrooms plus 1 is how it should be sized. Next slide. So the tool will give the results in total required ventilation rate. It will also give you its infiltration credit, and then the difference is the required mechanical ventilation. So if you see on that top section, dwelling unit ventilation results, 41.5 CFM is the continuous flow rate required by ASHRAE 622 in this example, including the infiltration credit. So this means that a ventilation fan must either run continuously at 41.5 CFM, or it can be a higher CFM, and you can use this runtime solver to determine how many minutes per hour whatever size fan you have should run to be equivalent. So in this example, if you had a fan capacity of 60, then you would set your timer to be 41.5 minutes per hour.
And so the infiltration rate is just the normalized ventilate or air infiltration based on the blower door result that you entered here. That's why the blower door results are critical here, because if you don't have a blower door result or you can't do a blower door test, then you can't use the infiltration credit, and then your results are going to be higher. Your required mechanical ventilation rate is going to be higher than if you are able to account for the air leakage in the building as tested. So that's just something to be considerate of.
And it's also worth mentioning that when we're talking CFM, we're talking measured CFM, a measured result from your fan flow meter of how much CFM that fan is actually moving. Now, the variable speed fans you have now are very good at overcoming duct pressure and can usually flow pretty similar to what it's rated at. But if you have a long, high resistive duct lane, then might get flows less than what it's rated for.
So
next slide.
We're going to jump through that.
Right, I think this is the last one I'll do, Steve, and then we'll hand it off to you.
Okay.
And so this is just a summary. So a ventilation system is, at a minimum, an exhaust-only system that is Energy Star or otherwise quiet and low wattage. You can use ERVs, HRVs, or inline fans. Those are all options. But the most common by far and the most easily installed is in a bath fan scenario. So the fan is just part one of the system. Part two is the control. The fan must be either set to run continuously or have a programmable 24-hour switch for automatic operation. The toggle switch in the fan can't just turn off the ventilation system. It has to be something automated. And then three, the fan must be tested in the CFM that's required by 62.2 met and confirmed by the testing. So those are the three key points: the fan quality, the control being present, and the fan moving the correct CFM.
Then also for a fan to be used in this purpose too, it kind of comes under the Energy Star requirement, but continuous duty, the fan must be rated for continuous duty as well too.
Yes, that is an underlying piece to this, and was really the only thing that used to be listed in 6289. But what's happened is that with the switch to really zones being, quietness being the requirement, all fans that meet this quiet low wattage criteria are continuous duty rated. But yes, continuous duty is key.
Okay, just figured take a quick second here to see if there's any questions. Nothing?
Can you guys go through the different type of timers that are available to use with the systems?
That's the next section. Yep.
Okay, very good.
So yeah, you're thinking ahead there, Jamie. Thank you. All right. Well,
There's a question Lisa just posted in the chat. Attic volume is considered part of the building height pressure boundary even when ceiling is airtight. So when determining the height of the building, you only want to include the height of the uppermost layer of the thermal boundary. So if an attic is a conditioned attic and you've insulated the roof slopes, then the height you use is all the way up to the peak as the height. Does that answer your question?
So like in this visual example here, if you look at the gray ceiling plane, if there was not that cathedral ceiling in that living room there, and this was just the thermal boundary and airtight ceiling was at the 8-foot ceiling height, that would be your total height that would be used for the calculation versus what's shown in the example here because of the cathedral ceiling in this drawing.
Yeah, and that's to clarify, that's just the height, the height input for the tool. If you're asking about whether the floor area should be included, generally, no, never would an attic floor area be included because it's not occupiable space.
Yeah.
With this picture right here, would you say the cathedral is insulated to the peak, but then you insulated the attic flat continuously down? Do you think average that out or no?
You mean have two thermal boundaries? What do you mean?
No, it's like that. The cathedral's slopes are insulated, but then it connects to an attic flat at
Highest
the
point.
bottom right there. Yeah,
highest
point. So just the highest point. Okay, you don't average. Okay.
Right. Yeah.
Yep. Oh.
It's really to determine stack effect. So that's why it's the highest and the lowest point.
Okay, so how do we get there? Now we're going to get into what options there are available to actually meet the requirements that are going to be defined by the ASHRAE calculation. So again, Energy Star is kind of what we're suggesting is the pathway to take. Just look for Energy Star model equipment because that meets the performance criteria that Matt was just talking about. And in that vein as well, too, there are simple basic fans, and then there are fans that have integrated controls that are designed by the manufacturer for this actual purpose. So manufacturers have lines of exhaust fans in their product offerings that are designed specifically to meet ASHRAE 622 requirements in residential buildings. So some things to look for are fans that have integrated speed and timer controls within them. So if you're replacing the fan, these are models that you can do the controls fully integrated into the fan itself and still can be wired with a switch. So if the occupant or the owner wants to boost the fan while they're using the bathroom, that option is still available. So, there are ways that these fans can be set up to run continuously or to be run on a timed delay. But this intent really for this type of fan is that it's run in a continuous mode and you're setting the fan for that required purpose. One thing to be aware of for these types of fans to run in that continuous mode is that they do need to be direct wired, which means the typical setup of a fan and the operation of the fan being powered from the switch itself may not work. You may need to find a new way to feed the fan directly. So, as Matt was talking about earlier, if you're working in an attic and the scope of work is to air seal and insulate the ceiling plane, and there are 1 or 2 bath fans in that ceiling plane, it's an ideal time to be replacing the fans, and it also makes the ability to run wiring that would be required for a continuous duty fan to be done a little bit more easily in those scenarios. So this is the type of fan you'd want to be looking for the purposes of compliance. And then working with fans that maybe are not set up to run continuously or designed for that purpose or have the integrated controls. There are different switches available or controls on the market that can be used to control different brands of fans. So it's not brand specific here. But this type of control would be to replace the existing switch or control in the bathroom to be able to operate a fan, and the fan that actually meets those zone and wattage requirements and continuous duty requirements already. So if there's an existing fan that would be considered compliant, this type of control can be used in place of the existing switch to create the timed or continuous control of that fan, and then still have the ability to use the boost operation like I was just saying. So the occupant can still turn the fan on for high speed or boost when they're using the fan. These types of switches can be just wired into the box in replacement of the existing switch without the need for a new feed. So that does make it a little bit more easier to meet the requirement with a compliant fan without having to rewire everything up in the ceiling. So just for an example of how these things work, if you have that fan that needs to run for 20 minutes an hour to satisfy the ASHRAE defined CFM rate for the building, then the fan will be set to automatically come on for 20 minutes an hour. But then if an occupant comes in and turns on the switch and boosts the fan speed, that'll be accounted for in the timing rate of the 20-minute operation. So there's ways that it doesn't mean that if you have someone using the bathroom frequently, that the fan's going to over ventilate typically. The way that the control is set up is that it keeps track of and accounts for user input into the fan into the automatic cycle that it's set up to run for. So if you have a compliant fan, or you can get a fan that meets the specs in the ceiling, this is a control that can be integrated into that system to operate it to meet the continuous requirement for the house. So that being said, in RBs, there is requirements for local ventilation, meaning that if you have a bathroom with anything that's going to be creating excess moisture, bathtub, shower, etc., that if you are not using that fan for a whole house system to be run continuously, then it needs to be 50 CFM intermittent, or if it is going to run continuously, it needs to move at least 20 CFM. So if you have a fan that's going to be doing both that local requirement of either 50 or 20 CFM and being used as a whole house fan as well, then based on the number of bedrooms, you need to use a minimum rated capacity fan for that purpose. So, this is a reference that's in RBs. So when you're sizing the fan that would be used to meet this requirement, you have to be considerate of number of bedrooms and what that minimum CFM requirement would be. Another thing to take into consideration, if you are needing to install a whole house system here and add additional ventilation to what's there or control the ventilation that's there, is to either just you have a choice. You can use one fan to meet that requirement, and questionably whether or not that's going to provide adequate whole house ventilation if just one fan is running on a timed control, versus distributing those CFM amongst more than one fan in the house. Or there are other equipment options available where you can start to integrate ventilation into a ducted forced air system in the home that can bring in the outside air and ventilation air into an air handler and move air around the house as well too. But more simply, if you have a 60 CFM requirement based on the ASHRAE calculation, you could shift that 60 CFM to 2 fans and have 2 fans set to run to meet that 30 CFM based or split amongst the two, either on a time control or running continuously as well. So it's something to think about in conversation with the occupants and the customers too. If they're already dealing with issues of high humidity or moisture or indoor air quality, the better benefit to the occupants is going to be to try to spread the love a little bit, move some CFMs around the house, not just rely on one point source and one fan to do that work. If you start to read deeper into what the code calls for a whole house system, then it starts to address how that air needs to move through the home, undercutting of doors, etc., pass through vents, things like that. We're not looking for that to be done for home performance. We're looking more for the fan being in the home and appropriate fan and set up properly to move the required CFM. But that is where the code starts to take into account how to get ventilation air moving throughout the house if you do not have a balanced distributed system. And when you're in the home for the initial visit, you really need to be taking a look at what fans exist in the home in the first place. You know, evaluating whether or not what's there is even effective or running, you know, regardless of whether or not the house is going to need ventilation. These are things that we should be looking at for feedback to the customer, because there's oftentimes where even if you run the calculation, the house isn't very tight, you have a requirement of less than 15 CFM, there may very well be a real need to replace fans that are there already because they may just not even be moving any CFM whatsoever and not ventilating a bathroom when people are taking a shower. There's signs of mold on the walls in the bathroom, et cetera. So testing fans really should be a part of what we're doing in the initial site visits. So using your pressure pan and your manometer to be able to just see what you're getting for CFM from the fans that exist in the home already. And then also just being aware of where to look for model information about the fans themselves. So, you know, taking off the housing on the fan and looking up into the fan unit itself, look for the nameplate. You may find and get lucky that there's already a modern fan in there that would be considered compliant for whole house operation. The only thing that's missing there is a control. So that's where you have an opportunity to not have to completely replace the fan and rewire things, but to be able to use the existing fan with a control that will allow you to get that operation and meet the CFM requirement. So look for the nameplate model info. You can always look up the model and see what comes back from the manufacturer as to whether or not it's Energy Star. Usually if it's Energy Star, you're going to see that label inside the fan housing itself as well. But when it comes to meeting ventilation requirements per ASHRAE, I mean, ASHRAE doesn't, there's more than one way to meet the ventilation requirements for a home. It can be exhaust only, it can be supply, it can be supply and exhaust, it can be balanced. So, you know, why we're getting to this point of needing to be more diligent about affecting ventilation in homes is that you know, exhaust fans, when you're using exhaust systems to create your air exchange, you're relying on infiltration through the building shell as your supply air, as your makeup air. And, you know, we've always talked about the detriments of that, of where that supply air or fresh air, quote unquote, is coming from. But also, you know, housing that is being built now and has been being built under modern codes, the air tightness requirements are minimizing the amount of infiltration we're getting through the building in the first place. So the tighter the house, you know, the less effective exchange you're getting in the first place. So, you know, exhaust fans in an existing home are still going to be the typical go-to and method for meeting the ventilation requirements. Be considerate, though, of what type of fresh air exchange is going to occur in that home when using that type of equipment. A balanced system, you know, that's exactly what it is. You're not creating negative pressure in the home. You're bringing in a equivalent amount of supply air as what you are exhausting from the home, and you're getting the benefit of heat exchange, and you're getting the benefit of filtration. You know, you'll be able to filter what any pollen or pollutants that may be coming in from the supply side when using a balanced system. So, you know, these are options as well for the program, but, you know, putting an effective balanced ventilation system into an existing home is challenging. It's challenging putting them into a new home often because they're kind of considered as an afterthought and they're not always designed into the layout and the needs of the home, because, you know, an HRV or an ERV has the potential and the capacity to perform a certain level of air exchange at a certain level of efficiency, but it's one part of a greater system, and the duct system of how that air is distributed is just as important, if not more important, than the piece of equipment itself. So, you know, these are options, as like we said, for compliance here with home performance. But again, you know, there are scenarios where this could be a factor, but more often we're going to be talking about using balance or exhaust equipment. And just as a reference point, the 2024 code, which is now, it's your choice, fielder's choice, between 2020 or 2024 code that you need to meet for new construction. And just as a reference point, what is in the 2024 code, which for the 2024 code, that shifted from exhaust only still being allowable for new construction, where now whole house balanced heat recovery ventilation would be required if you're complying with the 2024 code. And for the 2024 code, a minimum sensible recovery efficiency of 75% was required, and 1.2 CFM per watt of fan efficacy for any ERV or HRV being used in the home. So just putting this in there as reference, if you are having conversations with the homeowner about balanced systems and HRVs or ERVs, this sensible recovery efficiency and fan wattage is something to be considerate of in those conversations. And the reason you might want to think about that in an existing home, and another factor to be paying attention to when you're doing your initial site visit and evaluation, and then understanding where you're headed as far as your air tightness goes for the work that you're doing on the home, is being aware of the potential for backdrafting combustion appliances. So if you're going to be reliant on an exhaust fan to be doing your mechanical ventilation for the building and being compliant, you need to be aware of what impact that may have on other combustion appliances and or what compounding effect it will have because of other exhaust equipment in the home. Proximity to vulnerable combustion appliances as well is something to be keeping an eye out for. So the most typical thing we're worried about here, and the most obvious, is atmospherically vented equipment. So atmospherically vented equipment into a chimney is reliant on combustion air from within the building, and that combustion air is also that air within the building is also required for draft. And open atmospherically vented gas water heaters are one of those really kind of critical pieces of equipment to keep an eye out for. If you see these in the home, then this should be a conversation to have with the homeowner. You can look for areas of evidence of backdrafting that's occurring already. And in a scenario like this, you wouldn't want to be necessarily putting in more exhaust equipment that's going to make these conditions potentially worse. So you at least need to be diligent in these scenarios as well about your combustion testing, making sure that you don't have circumstances where what's there already is not great and probably should be considered remedying in some way, shape, or form with either bringing in fan in a can or some sort of combustion air to the appliance zone, and or changing the venting type for the equipment that's in place if you have to be bringing in new ventilation into the building. So it just underscores the need to be looking at this holistically, and again, anticipating things ahead of the work scope being installed. It's much better to get ahead of this stuff than it is to be reactive to it after work is complete, and then you're trying to figure out what to do then. So this is just a summary of conditions to be aware of. Multiple appliances that have high capacity for exhaust. A kitchen remodel is something, where you put in a high-end new kitchen exhaust range, and that can have major impact on equipment that's already in the home. So one type of work in the home you wouldn't think would have an effect on appliance or combustion equipment may very well be having a big effect. So again, just level set some things to be keeping in mind as we're looking at, moving air in and out of the building mechanically. So just to summarize everything that we've been talking about here today, and Juliana, I don't know if you want to jump in here now or if you want to jump on in the next slides, but I'll just open it up to you at this point. But the summary really for what we're looking at here is just start off by taking a look at what equipment exists in the home. Anticipate where you're heading based on your blower door results. Have these conversations with the homeowner at that initial visit as well. Level set for the reasons why this is something that either may quote unquote have to come into play, but more so why they should be considering the benefit and need of having an adequate mechanical ventilation system running in a home. This has been required by code ever since we've had the residential energy code. But most often, the reason why you folks are having to do this type of work when you're doing weatherization is because that initial requirement for an adequate whole house mechanical ventilation system was not taken into account when the house was built. So now it kind of comes along on the train with the work that we do in weatherization. Get familiar with the RedCalc tool. It's very easy to use and user-friendly. If you have any questions for how that tool works, reach out to your EC. It can walk you through it. How to get the work done too, the complexity of what you need to do. If it's as simple as just swapping out the existing switch with a timed control, you may be able to take that on your own. But, if you're talking about bringing a new supply line for wiring a new fan, replacement of a fan, that may be out of scope for the work that you and your company can do. So, think about either who your allies are that you can work with as subs to do that work, or just make sure that those are things that your homeowner is aware of in your initial visit before you commit to doing a weatherization job, so that they can figure out a pathway to take care of that on their own. Yeah, so I think that summarizes things. Bradley, do you have a question? And then I'll hand it over to Juliana.
I saw that Tom Berry, he was saying that he thinks it's from the above grade, not the basement floor. Is that true or no? When you do the calculation, when you measure, so basically, if the basement's finished and it's all below grade, it's not walkout, but it's completely finished with the TV, couch, would that be considered then? Or no?
So the height of the building, which is the part of the calculation, the height of the building is from grade to the highest point of the thermal boundary. And the floor area is completely different set of rules. Is it finished occupiable space? So in that scenario, the finished basement is, yes, part of the conditioned floor area, but the height of the building only starts at grade.
Okay.
Any other questions?
Can you go back to the wiring diagram for the timer? I'm just trying to figure out what the most common kind of wiring needs would be needed in the case where a timer needs to get added. So would they need to run a separate power line from the switch up to the fan? I mean, typically in an old house, you've got a fan, a combination light and fan often, right? Like one switch is going to turn both of them on. And I'm just wondering with this, if they add a timer, they replace the existing switch with a timer switch. Do they have to add another separate power line, a separate line for the fan up to the unit? So going from the switch up to the wall to the
You
unit.
may, depending on the type of the fan and the control for how it's set up, what's in the fan itself. This switch is more or less set up to operate a fan, not handling, but you do have the ability, based on the existing switch wiring, to integrate that into the setup with this switch. So if you look at the wiring diagram, you do have a lead there for a separate light and fan. But I think when it comes to the wiring needs, you're gonna have to go by the wiring schematic or details from the manufacturer for the fan for the switch, and for what exists for the fan as well too, for how the fan's operated.
But I would just say that these switches, at least most of them, are designed to be used with existing wiring. One set of wires. Now, what you might come into is if you have your light wired to come on when the fan comes on,
right,
you might not be able to avoid that with the existing wiring unless you rewire it to be separate.
Gotcha. Okay, so the simplest way to put it in would be just assume that the when the fan's on, the light's going to be on. And then you probably don't need to add another wire.
Probably in the scenarios where that's how it's wired. Yeah.
Yeah.
Okay, but yeah, I think you're gonna have to reference what the wiring info is from the manufacturer, and then also, if you can, reference back to what the fan manufacturer's wiring requirements are as well.
Right. Thank you.
Yep.
Okay, I will close this out here with just a little bit of there's all the great information out, what you need to know in the field, what are you doing, how are you scoping it, and then this piece of just what do you need to submit to Efficiency Vermont for your projects associated with ventilation. So if you scope ventilation during your initial visit, or ventilation is going to be needed in this home, is going to be a part of your project, you need to add a mechanical ventilation product in the ORC. So there's a screenshot here showing of what that looks like. So it's under the product section. This is where you're adding that air sealing measure, insulation and stuff like that. It's just under the health and safety category. So this is something the team will always be looking for. And just noting that at pre-approval, if an EC identifies that a home might require ventilation and there is no mechanical ventilation product included, they may reach out or return it to you for additional information. To make your life easier, I'd recommend just upload a copy of your red calc for the home to any of the document uploads that are available in the ORC. So under the invoice section, the blower doors one, you can upload multiple photos. And it can be a photo, a copy or a printout of, or just like a PDF of the red calc, whatever, it doesn't matter the format. That does always help in an EC's review to just ensure. So I would just encourage, if there is a need for ventilation in the home, and even if you're not the one doing the ventilation work yourselves, we expect to see a mechanical ventilation product on the project in the ORC. Okay, next slide. Spaz, did you want to talk to this at all?
Yeah, I just wanted to give you the reference points to look for on our website of where to find any upcoming trainings that we're going to be offering, either webinars or in person on ventilation topics or other topics as well. Doing a code training tomorrow in Winooski. This is an all-day code training covering the IRC and RBs. So that's just an example of ongoing in-person trainings that we have going on that are listed on our trainings and events calendar. And then also we have many other sessions, recorded sessions on ventilation topics that are available at any time on the recorded online trainings link, also on the website as well. So, you know, if you're not used to going to the trade partners section of our website, you go to efficiencyvermont.com and then look at the very top heading of the page. And at the top right, you're going to find the links to the trade partners site, and then that's where the trainings and education information is available. So, and I think Bryn may have just put a link to that in the chat as well. So thank you, Bryn. But yeah, that's where you can find other, again, in person or recorded trainings of ventilation or other topics.
Okay, that concludes us. We'll see you all again Tuesday, November 4th for our normal contractor call. We'll stop here and also see if there's any more questions. We still have time and we're here to answer any questions, but we'll make sure to do more ventilation trainings throughout the next year. And please always contact your EC if you have any questions, and they're happy to help talk through any ventilation needs specific to projects or just in general. We have a question in the chat. If a cathedral ceiling only takes up 10% of house, same calculations?
Yeah, the height is based on the highest point. So even if it's a small portion of cathedral, the height of that cathedral will determine what you use as a height in the calc. Hopefully that answers it for you, Mitch.
Okay.
Okay,
I think we
well,
don't have any other
definitely,
questions.
yeah, just definitely reach out to us. You know, that's what your ECs are here for, is to help walk through these things with you. And yeah, if you need any further support as far as CAS testing as it relates to ventilation requirements as well, let us know. We can, you know, start to dig into that more deeply with you as well too.
Great. Big shout out to Spats and Sharp for the presentation today. Thank you guys. Have a good rest
All
of your
right,
day, everyone.
take care, everybody.
Till next time.
It doesn't like on this one for you because you're gonna be there. We don't stay. It's still and maybe like you're gonna have like this inspector, but ultimately, whatever this inspector says, like if he's like, "Oh, do this," and you're like, "That's a terrible idea." You don't have to sense. Yeah. I never did. Like, I'm just not sure. And it feels like. I should everything out. Don't pull it down into cases with the hose up like this. And it runs through all the handles bag and set it off. Yeah, but you're really going. It's not good. Also, be sure see that the same fire. This is just to see how they stay. I'll let send that and should be. Okay. Yeah. Understood. Yep. Yeah. All right. Okay. Sounds great. Thanks, Bradley. I know it. That's this game up.